Good evening, everyone. Thank you for joining us today on our webinar titled The Shipping Industry, Things You Thought You Knew, but Were Afraid to Ask. My name is Alexander Kotrumbis. I'm the head of the Department of Maritime Studies at New York College. I am a lawyer by profession, both in Greece and in the UK, specializing in international commercial and shipping law, a practitioner, and also a very proud member of New York College. Before we begin, θα ήθελα να πω δύο λόγια για το κολέγιο. Το New York College είναι ένα από τα κορυφαία κολέγια πανεπιστημιακών σπουδών στην Ελλάδα και το μοναδικό με διεθνή εμπειρία, με δυναμική παρουσία σε Αθήνα, Θεσσαλονίκη, Πράγα, έχοντας ιδρύσει βέβαια και το University of New York in Prague, το θυγατρικό ιδιωτικό πανεπιστήμιο του ομίλου εκτός Ελλάδος, στην καρδιά της Ευρώπης, στη Δημοκρατία της Τσεχίας. Στην παγκόσμια κατάταξη εκπαιδευτικών ιδρυμάτων στην Ελλάδα, το New York College διαβαθμίστηκε ως ένα από τα κορυφαία ελληνικά κολέγια, σύμφωνα με τη μελέτη που συνέταξε η Μονάδα Διασφάλισης Ποιότητας του Εθνικού και Καποδιστριακού Πανεπιστημίου Αθηνών. Το New York College προσφέρει πολλές διαφορετικές ειδικότητες σε 6 σχολές σπουδών, 80 τίτλους πτυχίων και σε συνεργασία με 4 διακεκριμένα κρατικά πανεπιστήμια Αγγλίας, Γαλλίας και Αμερικής. Είμαστε περήφανοι γιατί το 90% των αποφύτων του New York College βρίσκει εργασία στο πρώτο εξάμηνο μετά την ολοκλήρωση των σπουδών του, χάρη προφανώς στο διευρυμένο επαγγελματικό δίκτυο του New York College στην αγορά εργασίας. We're here today to talk about shipping. So before I begin, and before I introduce my lovely colleagues, the shipping industry, of course, is an industry that knows no borders, with exposure to international markets and trade, and anyone who chooses to make a career in this sector would obviously have to choose a university institution that meets those standards. So the School of Maritime Studies, for those of you who don't know, was founded in 2006, with graduates now staffing leading shipping companies around the globe. The college offers degrees in collaboration with the University of Greenwich in London, both undergraduate and postgraduate degrees, obviously taught entirely here in Greece. This well-established partnership has, of course, provided a long list of graduates with successful careers and has given us, obviously, the competitive advantage we need for them to advance in this very competitive industry. As we are all professionals in the field teaching in our postgraduate degrees of the MSc in Marine Engineering Management and MSc in Global Shipping Management, it's a great way for me to introduce our 2 speakers for this evening, Mr. Kotάκης, who's here with us, and Dr. Kockarakis, both teaching at the NYC programs. Good evening, both of you. I do believe that the best way forward today, after discussion, was to introduce Dr. Kockarakis first, so that he can obviously speak to us about vessels and fleet and obviously commercial management. Before he begins, a few words about his very extensive career. Dr. Kockarakis is a graduate in naval architecture and marine engineering from the National Technical University of Athens. He holds a graduate degree from the University of Michigan, an MSc in Marine Engineering Management and MSc in Mechanical Engineering, and of course a PhD in Naval Architecture and Ocean Engineering. The CV is very extensive, and we're very proud for him to be with us. He worked in various projects worldwide as a consultant and a technical advisor of maritime accidents. The most notorious were, of course, the explosion of the Space Shuttle Challenger, the grounding of the Exxon Valdez, the explosion and fire of Piper Alpha, the capsize of drillship Seacrest, and of course many others. Furthermore, he was a consultant for numerous aspects on container ship design, operation, and repair. He has extensive experience in ship design and operations, spanning over 40 years. He's currently working at Bureau Veritas in charge of technical development and troubleshooting, focusing on the implementation of the green regulations, fuel-saving techniques, energy efficiency, speed and hydrodynamic optimization, resistance and propulsion, performance monitoring, ship design, machinery and safety, education and training, asset integrity management, and, of course, alternative fuels. Thank you so much for being with us today. As I've already said, I mean, we are colleagues at New York College, but your extensive career, I can always, I'm just always grateful that you're here and taking the time off. So please welcome Dr. Kockarakis with his presentation. Over to you.
Thank you, Alexandre. I would like to extend a warm welcome to the attendees of this webinar and greetings from the island of Cyprus, where I will be until this Sunday. When I picked a topic for today's presentation, I wanted to give you a summary of the course I'm teaching rather than focusing on a hot potato topic like regulations, the fuel of the future. So I picked the description of the course which I teach, the Vessel and Fleet Technical Management. So the course starts with a description of what is a vessel, the various types of the vessels, and the focus is to familiarize the students with the terminology, because in your future jobs in shipping, you have to be able to recognize the various terminology, the jargon of the trade. So we go through description of the variety of types of ships, and we underline the characteristics of each one, the basic characteristics, and their pattern of trade. Of course, there is no, in order to complete the course, we enter the area of naval architecture, but not in a sense that is being taught in, say, in the School of Naval Architecture. It is what I would call naval architecture for non-naval architects. In my career, I worked with lawyers in legal cases, and of course, I had to simplify the science so they would be able to understand and testify and discuss at court. So we discussed the main characteristics of the vessel. For example, I will give you an example. We talk about tonnage, gross tonnage or net tonnage, and this is not tons. It comes from tune, which is a volume unit. So when we say 400 gross tonnage, we mean 400 cubic meters of useful space. So we go through the basics, draft, air draft, length. There are different, if you say the length of the ship is so much, you practically say nothing, because there are 6 different definitions for length. But you have to know the 2 basic ones. As you see in the picture, the length between perpendiculars and the overall length, those are the critical ones. Furthermore, we talk about the lines of the ships, we talk about stability, what are the basic modes of stability, how we load the vessel. You probably have seen, those of you that are from shipping, from schools, like captains or engineers, you know this so-called plimsoll mark that indicate up to which point you can load the vessel. And of course, there are different marks depending on the place you are in the world, like tropical, like summer and winter, because the density of the seawater changes, and of course the buoyancy, so the sinking of the ship changes depending on the density. Always we have equilibrium, the buoyancy of the acting on the vessel equals the weight. We cannot exceed the allowable full draft of the vessel. Very important is the response of the ship to the ship waves. So we have different movements. We touch this not in a great detail because, of course, remember, naval architecture for non-naval architects. Then we go through the ship structures, how the ships are made, what are the basic components that put together they make the whole construction of the hull. When we say hull, we mean the ship. The blocks, here you see one of the blocks, many blocks together make the whole ship. We see corrugation. Why corrugation? We explain in the course. We have the ships are not rigid; they deform under the action of waves. So we have the so-called hogging and sagging, depending on the load on the vessel. Very important is the organization of shipping companies. You see here a graph that indicates the basic departments of a shipping company, and you see the position of the ship owner. A lot of times, one vessel represents one company, and there are various departments from insurance and chartering, technical operations, which they pick the crew, and so on. With this, we analyze, and it's one of the favorite topics in the exam. Then we have the surveys. What are the surveys? What types? We have classification surveys. I work in a classification society, the French Classification Society. We have statutory, which are performed by the class on behalf of the flag of the vessel. And we have various other types. We have port state officers boarding a vessel to make sure that everything is okay. You see some examples to avoid where you see heavy corrosion and holes. The problem with the holes is that we don't have water tightness. You don't want water to start entering the vessel because then you lose the buoyancy and you have a problem. You lose stability. Of course, we could not avoid talking about the engines. Again, not in great detail because it's a huge topic, just description, rough description. We have, of course, the king of propulsion, which is the diesel engine. Not so much the turbine, the steam turbine. It's an expensive plant, so it has been abandoned today. About propellers and about what takes the forward force on the propeller. It is on the vessel. It is the so-called thrust bearing. You have to know this terminology, and at least we touch on them. Some of the problems, you'll probably work in a shipping company in the future. You have to know what you will be faced with. One of the most critical ones is the corrosion and the coatings that you put to protect the steel. Corrosion is natural phenomenon in vessels, and you see here the results of corrosion. Reduction of thickness makes the parts thinner and easier to break. We have pitting. Pitting is holes on the steel parts, and to protect, we put the so-called coatings. You see an example here of a very nice coating which is sustained over the years. You know, ships have a lifetime of about 25 years. So we have to make sure that they will be okay all this time. Here you see an example of blisters. This is not a good application of coatings. There was dirt on the steel part that created this blistering. it is very important, and those of you that are professional mariners, you know that this is a requirement. The so-called STCW, it's standards for training, certification, and watchkeeping. They describe the qualifications of captains and engineers, and also first, second, third engineer, and also the captain grades. These are also important, and the STCW is a statutory requirement done by the International Maritime Organization. The IMO is the one that has published the relevant guidelines and regulations. An important part of the job is the dry docking. Prior to dry docking, you have to describe what you need from the shipyard, what are the services that you will require. You send it to a few shipyards to get a proposal from them, financial proposal, and then some of you will have to be there physically to supervise the job and make sure that the job will be done properly. So one good product of the class will be to learn how to write dry docking specifications. Of course, you will hear about insurance from Alexandros Κουτρουμπής, who introduced me, because he's a lawyer, but insurance is important. So we will discuss about insurance, how to claim, what is allowed, what is not allowed. This is kind of a complement in the course. It is an important part. There is also an insurance department in a shipping company, in a well-organized shipping company, because there are various types of insurance, and we have to go through those. I would like to point out that if there are questions, feel free to ask after the end of the presentations. I'll be more than happy to discuss with you. Then we have what the International Safety Management Code. This is what we call a statutory regulation. Statutory regulations are the ones that are mandated by IMO, and they are the responsibility of the flag. And the flag usually, because it doesn't have the manpower and the resources, delegates their check of implementation to the class, and the class takes over, makes sure that things are okay. There is certification that the vessel is safe and seaworthy on board the vessel, the SMC, Safety Management Certificate, and also there is a similar certificate for the office, for the onshore operation. Both have validity of 5 years, and after 5 years they have to be renewed. They are audited annually or every 2.5 years for the vessels. It's more difficult to visit the vessel, and it is an important part of our work. Of course, the vessels are a dynamic entity, and as going through the water, they are attacked by cells, by dirt, slime. Slime is the easy part, but you can see here a series of cells practically welded on the hull. And the problem with this is that they increase the power to move the vessel. They increase the friction of the vessel as it goes through the sea. So to avoid that, we put biocides, the so-called anti-fouling protective coatings. This is also important, and it is a major job that we do during a dry docking of the vessel. This is a major expense, and but it is necessary. And the the smoother the antifouling, the smoother the outside surface of the ship, the lower the friction that is exerted on the vessel, the lower the power that is needed to move it, and the lower the fuel consumption. Fuel consumption today is important for various reasons which we discuss in class. The most important is the carbon dioxide emissions. Please remember that 1 ton of fuel, heavy fuel oil, for example, emits 3 tons of carbon dioxide. So if you have a vessel that burns 40 tons of fuel, it's going to emit in the air 120 tons of carbon dioxide. Given that we have about 60,000 ships in the fleet, you can imagine what happens in the atmosphere and why we experience 45 degrees during July and August. A very important part, but it is an unfortunate, inevitable occurrence, is the damage. Ships are grounded, the propeller touches the ground. You see what happens in a bulk carrier. Those are the so-called frames of the bulk carrier. When one frame breaks, the adjacent one takes the load. So usually it becomes deformed. There is a problem. Here you see one of my favorite topics, a crack. You see this crack, and we will talk about cracking, just the basics, but if the crack reaches a certain length, which we call critical, it's going to propagate in the steel with a speed of sound in the steel, which is about 4 kilometers a second. There is not much that the crew can do. The ship will be cut in two, and this is something that you don't want to occur. We will talk about fuels, about conventional fuels. Depending on the interest of the class, we can go into more exotic fuels like ammonia, methanol, hydrogen, LNG, depending on what interest there is. But we talk about the properties, the handling and the treatment. You can't just take the fuel from the fuel barge and burn it. You have to clean it, filter it through separators. And also, we talk about lubrication, the lubricant properties, and the lube oil treatment. It is important for the bearings to be protected by an oil film which assists them to withstand the load. A very important part of our job is to make sure that when we order a new building, we include all the loopholes that may happen, because the shipyards are not working for you, they're working for themselves. So it is important to know what to check. So we will go through and we're going to point out what to look for. There is a very limited guarantee after you get the vessel, only 1 year. You know that, of course, I will show you the bathtub where in the first year many damages occur, but not all of them. You have to achieve a certain speed, a certain draft, a certain dead weight, a certain fuel consumption. If those are exceeded, the shipyard has to pay penalties. And this has to be specifically spelled in the new building contract. So in case you review a new building contract, you have to make sure that it is there. We mentioned about the bathtub curve, which you see here. In the beginning, like assume you bought a car, in the first kilometers, you have a lot of damages which are reduced with time. We reach a point where they remain constant, and then towards the end of life of the machinery, the car, the engine, the number of damages or the number of problems starts increasing as well. We call this the bathtub curve because it looks like a bathtub. Important is to see what spare parts, how to buy spare parts, not the monkey parts. Avoid them as much as you can, as much as you are allowed, because they do not comply with the specs, and sooner or later they will fail. If you cannot do differently, make sure you pick the right ones. Also, when we check a vessel, where there is a lot of times there is pitting, especially in the bottom, because as you can imagine, all the junk, all the bad things will go in the bottom. So we have various degrees of pitting. These holes in the bottom are called pits. Pit in Greek is pigadi. So we see these holes, and depending on the pitting intensity, we accept or not accept this. If there is heavy pitting, the owner, the vessel has to change that plate. The thickness of the plates changes with time because of corrosion. So during the special surveys of the vessel, typically when it is in the dry dock, we have the ultrasonic guides that go there, and they measure with ultrasonics the thickness, and they compare with the initial one, and there are limits what percentage is acceptable to be reduced. I would like to finish my presentation at this point and like to tell you that environmental regulations are a very important part of the class. One critical issue is what fuel and how to pick the right fuel, as you can see here. What are the metrics? Shipping is going through a generational challenge, is mandated to reduce the emissions, the greenhouse gas emissions. So we have the so-called decarbonization, which we wonder is a midsummer night's dream or a hard reality. Is it a lion or a cat? 2020, those of you that were active, you know we have a dilemma of the low sulfur fuel or using or putting scrubbers or alternative fuels like LNG. I hope that I gave you a good idea of what the class will be. I hope to see all of you in the class and will accommodate you. I would like to point out that a lot of the stuff that we cover in the class and a lot of things are very practical. They are not theoretical. And after 5 years in the Polytechnio, a lot of this stuff I had not heard. So I hope you will have the opportunity to hear them. Thank you very much for your attention, and I will be very happy to reply to your questions.
Thank you so much, Dr. Kockarakis, for that. What you've just mentioned is very important. It's something that we always see in class. As stated previously, I don't know if everyone was here, but we have a lot of students with extensive experience, some students that work in shipping, students from naval academies. A lot of times they think they know something and they really don't, which is why we've also named this webinar, Things You Ought to Know But Were Afraid to Ask. We have the advantage of having professionals in the field, including our two colleagues here today. Everyone listening, I would kindly ask, obviously make notes of questions if you want. Please write questions as well. We can see those and we can have those after our final speaker. Before he also speaks to us, first of all, thank you, Dr. Kockarakis. Before he also speaks to us, both of our speakers will be here afterwards, by the way, to answer your questions. Nicholas Kotάκis, has started his career in shipbuilding, holding various positions in ship repair and new building projects in Greece and in Germany. In 2012, he joined French energy major Total Energies as regional technical manager of the Marine Lubricants division. And after passing from the position of technical director, Lube Marine, he's currently the head of the engine oils department at Total Energies Lubricants, based in Paris. Nicolas holds a bachelor's degree in engineering and naval architecture, a master's in marine engineering management, and an MBA from the University of Greenwich in the UK, and an executive master's in international business from the ESCP Business School in Paris. He's registered as a chartered engineer with the Engineering Council in the UK and as a European engineer with the FEANI. He's also a professor at the Department of Maritime Studies at New York College, and we're very proud to call him our colleague. So, Nicola from Paris, over to you for a very different presentation. And at the end, as we said, we'll have questions and hopefully a discussion. Thank you once again.
Thank you very much, Alex, for this introduction. Hello, everyone. Good evening to all our distinguished guests. I think that the presentation of Dr. Kocharάκης has been an excellent introduction to the subject. Of course, there are so many things that we cannot cover in half an hour. I will try just to, with my presentation, to broaden a bit the scope and the spectrum, talking about the current shipping environment, the challenges and the new opportunities that the shipping business is facing and will face in the near future, and the increasing complexity of the ship operations. So starting with, I think something that it is common knowledge to us all, that shipping is truly an international business. So you see in this map the maritime shipping routes and the main destinations based on the worldwide shipping routes in 2018. So clearly, this is a globalized world, but still there are some choke points like the Gibraltar, Suez Canal, the Cape, the Horn in Africa, the Cape of Good Hope, the Panama Canal, and so on. So it is clearly a global industry. It is clearly an international business, but this doesn't mean that there are certain very complex and very special geopolitical circumstances in different areas of the world. What you see in yellow are the 20 biggest container ports in 2018, starting with Shanghai in the first position, up to Long Beach in California in the 20th position. For those of you who might be interested, the port of Piraeus is found in the 28th position with about, I think, around 6 million containers in 2018. We're talking about shipping, and all of a sudden we have a slide over the GDP growth of different countries. Why? Because shipping is in fact the business that actually brings the world together and the international commerce together. So what you see here is the real GDP growth in different countries of interest from the years 2010 up to a forecast for the year 2027. We had, of course, in the early 2010s, the global crisis that affected the euro area. In Japan, we see how China was very strong, but with a declining growth rate, how India was growing strong, the impact of the COVID crisis and the COVID pandemic in the years 2020, and how things are projected to evolve based on the IMF, the International Monetary Fund, and its report back in April 2022. What's interesting to see is that India is clearly taking over in terms of GDP growth. China is coming second, but with a sort of declining rate. So we were used to having China, a GDP growth in the Chinese economy, which was above 7 and 8%. And now we see that this drops to around 5% or less, bringing a sort of stability for the world GDP at around 3.5% growth increase, which is a normal market expansion, with the USA, Euro area, and Japan being a bit more in a stagnation mode with a very slight increase in GDP in year-over-year projections. Why is this important? This is important because all this production of the world production, the GDP growth, we know that 90% or over 90% of this is transported by ships. By September 1st, 2022, we were counting 64,045 ships around the world, most of them being tankers. If we count all tankers together, this brings us up to, I think, around 16,000 ships, 13,000 ships in bulk carriers, 16,000 again with general cargo, and about 5,700 with container ships. So you can imagine that this is a world market. But what is even more interesting is that the order book and the delivery schedule a month ago was giving 3,277 ships. So 5% of the world fleet is currently in order book, is currently ordered, and will be produced. When the global economy is growing with a rate of 3% and the order book is at the rate of 5%, this means that we will have a surplus in supply compared to demand. This is a very simplistic way of seeing things, which makes it even more complicated if we check the dead weight that is currently in order book, which is 214 million dead weight, compared to 2,150 million dead weight currently at seas. This brings an increase of about 10% in our carrying capacity. Now, is shipping sustainable in all cases, in all sub-markets? Because every one of these types of ships is a sub-market, clearly. I think that it is safe to say that LNG carriers seems to be the future. From 700 ships that are currently at seas, or a month ago they were at seas, we have another 270 ships. It's an astonishing market, an astonishing increase that are currently underbuilt, which gives an increase in the carrying capacity of about 43%. Second market of interest is the container ships, and the third one is the LPG carriers. So we have three types of ships that they seem to drive the growth forward: container ships and LNG carriers. Today, DNV has issued its maritime forecast to 2050. It's the Energy Transition Outlook of 2022. And this shows the projections of one of the class societies from 2022, which is today, to 2050 in terms of transport work by main ship categories. And as you see, we know that at least in the next 30 years, shipping will be very much necessary because the transport work is expected to grow at a rate of about 20% over 30 years. Now, how is this demand? How does this break down in different categories? We see again that the gas tankers and the container ships will take a big leap ahead. We see that in gas tanker, the seaborne trade demand is expected to grow by 160%, which is 2.6 times more than today's trade demand, and container ship with 77%. So there is something to it. There is something that we see in the order book. There is something that we see in the long run as well. The LNG carriers and the container ships, they are a driving force, and it is clear because it is linked to the energies that we're using, to the decarbonization of shipping, and of course to the containerization of the global commerce. This has an effect to the new building prices, with the China New Building Price Index, which is an index used to compare the prices, the new building prices, reaching in August, in 30th of August 2022, so last August, the highest point over the last 11 years. So you see here the graph from July 1st, 2011 to 30th of August 2022. We have never seen so high new building prices in the last 10, 11 years. We see here the global economy slow down because of the Lehman Brothers crisis in 2008. We see here the effect of the COVID, and now we are leaping forward clearly. And we don't know if this will continue like this, but certainly this is a trend saying that there is a clear demand for new ships, for new technologies, for new routes, because the world population is growing and the world commerce will grow as well. Getting a bit more into the theory of the class as well, because my class is the strategy and management in shipping, but we do also some part that has to do with engineering and economics, clearly. So this source is from Buxton back in 1987. He said that the ship speed and the annual costs are linked one another. So the expenses for the hull maintenance of a ship, they remain mostly stable, irrespective of the speed of the ship. The crew and the insurance as well, it remains stable, but the machinery, the maintenance of the machinery has an increase, which is geometrically linked to the speed of the ship. And of course, the fuel consumption, the fuel bill, is clearly linked to the ship speed at a power which is close to 2.5 or 3. At the same time, the income follows a different curve. So the difference between the income and the expenses is what gives our profitability. So the ship owners are trying to find the profit by finding the right speed of the ship, which combines the best case scenario in terms of expenses and so P&L, profit and loss. The maximum speed is the speed of a zero equilibrium, and the optimum speed is where the profit is maximized. We know already that the capital and operating expenditures are expected to increase in response to the latest environmental regulations that Dr. Kocharάκης also mentioned before. We know also that there is a very significant difficulty in forecasting future fuel costs for each of the marine fuel options. So you will see in the next slides, there are so many different options today that it is really very difficult to forecast all the different scenarios. Even the class societies or the companies, the energy companies that are working in creating forecasts for the future, they're working on multiple different future scenarios, exactly because things are so unstable right now that we cannot predict with a certain degree of confidence what's lying ahead of us. So this difficulty will clearly push the costs to a higher level, and pushing the costs to a higher level will certainly decrease profit, and things will become even more worse, because there will be strong pressures on the income curve as well, because some of the ship types or the submarkets, they might experience low utilization rates. You have to imagine that all the container ships, they might be a blooming and a flourishing market, the same for the LNG carriers, but it will certainly not be the same scenario or the same case when it comes to tankers, to oil tankers, crude oil tankers, for example. A lot has been said about the decarbonization of shipping industry. When we talk about decarbonization, is clearly the reduction of the CO2 emissions reduction, or a zero CO2 emissions reduction, which is the ultimate objective and the ambition of all shipping players. And I tried to compile a sort of plan to understand what is this decarbonization, what are the four key options to achieving this decarbonization. And the one is the operational efficiency, reducing our energy demand, making ships which will require less energy. The second is the energy efficiency. So improve the efficiency of the energy that we're actually using. The third clear path is the transition to a low carbon energy. So we do not work with the emissions, we work with the source. We try to reduce or remove carbon from the source fuel. And the fourth option is the carbon capture. When it comes to operational efficiency, so reducing the energy demand, we're actually working with things that have to do either with the vessel design, so on a naval architecture point of view, working with optimizing hull dimensions, the construction weight, the bulbous bow retrofit, hull coatings, air lubrication, and so on. When it comes to the operational optimization, we talk about reduction of speed, advanced port logistics, weather routing, and so on. When it comes to energy efficiency, we have three subcategories. The propeller efficiency, working with large area propellers, body thrusters, ducted propeller. The efficiency of the engine system of our powertrain overall, with an enhanced fuel injection system, early intake valve closing, so variable timing, fuel economy lubricants or waste heat recovery systems, or power assistance and propulsion assistance like Flettner rotors, kites, sails, solar panels, anything you can imagine. When it comes to low carbon energy, we're talking about new fuels and new energy sources. LNG, which has been already discussed, batteries, ammonia, methanol, biofuel, fuel cells, or hydrogen. Solutions for the future, solutions that are more or less thought of also in other industries. So their level of being adopted in the marine business, it will certainly depend also on how they will fit to other industries as well. And finally, the carbon capture. So we cannot do anything to reduce the carbon because we cannot work on the operational efficiency or the energy efficiency, or we did our best in these options. We have worked with low carbon energy, and what is remaining needs to be captured on board before it being emitted. All this is what constitutes the shipbuilding industry of today. The operational efficiency is clearly something that preoccupies a big part of the work of the naval architecture offices today, but also the ship owners. The same goes for the energy efficiency, which is also linked to the different service providers or the machinery providers, the energy companies working on the low carbon energies, and the carbon capture solution providers for the carbon capture, for the CO2 capture. And we focus on the new fuels. Sorry for the heavy slide. We will not go through this right now. It's just to give you the overview, the landscape of what we're dealing with today. We have the fuel oil, the LNG, advanced biofuels, renewable gaseous fuels, hydrogen, ammonia, and methanol. We have different TRLs, which is a NASA system for the technology readiness level, about the fuel, about the engine, scalability, time market. All this is to explain that there is a very complex marine environment. We need to find the right solution, and every solution presents advantages and disadvantages. It's very difficult to say that this is the best thing to follow. By the way, I wanted to say that the source of this is the International Renewable Energy Agency, and this is a report that they issued earlier in 2021 that shows the different ways, a pathway to decarbonize the shipping sector. So this is a very complicated problem. There is no easy answer to this. We have a very international market with very particular problems, and we need to make this work. And to do this, and this will be my concluding slide, I see that the shipping industry of tomorrow will need to be manned with shore officers with high specialization and expertise. We'll need to hire well-educated and continuously trained ship crew able to cope with technologically advanced high ships, because the sophistication of the ships also grows. We need to implement a big data management philosophy, starting with a new approach to the way the information is transferred from ship to shore, and the way it will be subsequently managed, processed, and evaluated at shore. And of course, our industry, shipping industry, needs to be a pioneer in the technological evolution and the main contributor to sustainable environmental policies. Thank you for your attention, and I would be happy to answer to any of your questions.
Thank you so much, Mr. Kotaki, for your time. Thank you for coming back as well, Dr. Kokaraki. very enlightening. This is one of the advantages of having professionals in the field teaching classes where you can share your experiences, because obviously all your slides come from your own experience. I can see that from the chat so far, most of the people with us are actually maybe professionals in the field already. I can see that there's quite a few naval engineers, possibly working on ships, others working in shipping companies. So great to have those with us. We obviously, in terms of our master's degree, we have and our undergraduate, but postgraduate, mostly we have people making their first steps with other degrees, and obviously people who are continuing on and specializing. I have questions, and I've taken these out from a discussion here because I think these are things that people will want to know. So not trying to put my colleagues on the spot, but maybe something that we could possibly discuss. What is the future of what is the fuel of the future in shipping? I mean, Dr. Kockaraki, you are the person to obviously possibly answer this question, but both of you do have an expertise because Nico as well. What do you feel is the fuel of the future in terms of shipping?
Yes, actually, Nikos touched on it in great detail. I decided not to go into the details, but looking for the future, we do not know who will be the king and the queen of the fuels, because I suspect that there is no unique solution. I see a multi-fuel society in 2050. I see that there are going to be fossil fuels, definitely LNG, which is technologically mature today, will be there. Biofuels, although biofuels are not going to be available so much in shipping, they are going to be there, but they are going to be mostly used by aviation, the aviation sector. What is our hope is to have the so-called neutral fuels. And Nikos mentioned the carbon capture. I believe the carbon capture will keep the legacy of the fossil fuels, of the fuels that emit CO2. What is carbon capture? Is to take the carbon dioxide from the exhaust gases. There are various technologies. There are chemicals that can react with exhaust gases and withhold the CO2, which we then liquefy, that we make it liquid to reduce its volume, and we utilize it along with hydrogen to create the so-called electric fuels or synthetic fuels like methane or methanol or nitrogen and hydrogen, nitrogen from the air, they make ammonia. It is important to note that the electrolysis can take place from renewable sources or even nuclear energy. So the production of these fuels happens without emission of carbon dioxide. So these are going to be used in the future, all of them, the mixed, and along with various other modes of propulsion, electrification for short routes, will comprise the future fuel mix. And the Americans say there are no free lunches, there are advantages and disadvantages. We can talk until in the morning. About
this is what I would like to add to the very detailed answer of Dr. Kockarάκis. I fully agree with what he said. I think that we're going to a multi-fuel solution. I think that if we take a step back and we see things a bit more globally, there are things that we need to answer on the supply chain. So the one thing has to do with the availability. Yeah. The second thing has to do with the actual use, the actual practice. Are the people ready? Do they know how to operate the ships in these environments? And the third one has to do with the acceptability also of the society. So nuclear energy, for example, that was mentioned, it is an option, but is it acceptable? Are we ready to operate ships or to have ships calling different ports, carrying a small nuclear reactor? Is ammonia, which is a toxic fuel, for example, a solution? Or is it too difficult, too much to ask for the ship crew to handle? So I think there will be different streams. We see those streams creating right now. We have the liquid fuels, and the liquid fuels will mostly go towards a methanol solution. We have the LNG, which will most probably go towards ammonia. And then somewhere down the road, with maybe economies of scale and lower production cost, we might see hydrogen coming in, either in a fuel cell setup or directly as a fuel, mixing with other sources of fuel. But it is clearly the $1 million question right now.
Yeah, absolutely. I mean, obviously, the big one is as well the fastest way to reduce emissions. I don't know what your views are on that. Which one is the best one for that? Usually, when I mean, it's one of the few times that obviously we have the experts. I'm a lawyer, so I'm the one that has to clean up the mess if there is ever a mess. I would like to talk about EU regulations, though, because they're coming our way as well. I mean, any views on those? What will the impact be? Dr. Kocharάκης, I mean, if you want to talk about this, or
it is part of my job to warn my clients about the impact of the EU regulations. But today I'm going to warn the attendants of this seminar, if they plan to buy a computer, a car, or an electronic equipment, to buy it soon, because after the application, the motto of the regulations is that the polluter pays. But if you have a taxi and a taxi driver and a passenger, who is polluting, the taxi driver or the passenger? It's very difficult to decide. So in this case, we have a situation where there is a heavy burden on the cost of fuel, cost of emissions, if you prefer, the carbon tax. It is going to make shipping much more expensive, and I am afraid that the cost is going to be passed to the consumers. We are going to introduce a stock exchange on shipping. So ships will pay depending on the emissions of carbon dioxide primarily. So 1 ton of carbon dioxide will cost, at least today's cost is about 100 euros per ton. So this is going to create a chaotic situation because other countries all over the world, China, India, United States, will imitate this, and they will create their own regional regulations. And it is not only that, we also have FuelEU Maritime. It's a whole discussion. I'm not going to go into this, but my idea will be to wait for the International Maritime Organization to set up global regulations. The most appropriate and suitable regulator is IMO. Regional regulations create a chaotic situation.
Yeah, absolutely. Great. I'm trying to look through the comments as well to see if there might be questions that our viewers are asking us. I mean, a favorite one always is, what will ships look in the future? But that's one of the ones that we don't have an answer for either, I hope, or maybe you do. I don't know. Again, Dr. Kocharάκη, Mr. Kottakis, anyone who wants.
I think that it is clearly very difficult to answer, but I think that we should focus on the shipping education.
Yeah.
Because the question is not how ships will look into the future. The question is if we have the right people to operate them. And I'm afraid that the answer today is no, because technology is moving with leaps ahead, and we have to follow. And this applies both in the shore company, dock in the positions that we have at the offices, and both on board. And this is very tricky because 20 years ago, we didn't have a Tesla car. And now we do have a Tesla car. And if you drive a Tesla car, you see a huge difference in the way, in the whole mentality, in the whole mindset that this car has been built. And if this comes to shipping, with all these technological advancements and leaps ahead, it will certainly create a two-tier market and a two-speed market. And this is something that we have to be prepared for.
Absolutely.
Yeah, this is very correct. Nikos has an excellent point. And you can imagine the engineer, the captain, faced with a tsunami of paperwork because of the new regulations. They have to put down how much fuel, how much this, how much that. And they need to have some special training. If we have new modes of propulsion, they need more training and education. But if I like to venture a prediction for a complex question like that, and forecasts are dangerous, especially in these complex situations, and humiliate the forecaster. But coming from the island of Crete, I will dare say that in the future, we're going to have 2030. I do not expect dramatic differences. Ships are not going to change drastically from what they look today. Maybe by 2050, which is the target for zero emissions, we will see some changes. For example, new modes of propulsion. And going back to nuclear, there is a molten salt reactor technology, which is a nuclear propulsion, which is actually very safe. It is not Chernobyl or Fukushima type. It is safe, but the big question mark, as Nikos mentioned, is how do you convince the public that this is safe? So we expect some changes in the long run because of the evolution law, but not soon enough. Unfortunately, the changes are within the lifetime of today's new building, and I see my clients, the ship owners, to have to be hesitant to order new buildings. Remember the curve that Nikos showed. New building prices are very high, so this is another factor. So people do not like uncertainty. So we have to bring some certainty to the uncertainty.
Excellent. No, thank you so much. I think we should draw the webinar to a close. Thank you so much for your time, both of you. I mean, joined from Cyprus and Paris today with our two colleagues. Obviously, these discussions can continue in class, and I'm hoping we're going to have more webinars soon enough. Once again, thank you for our viewers as well. Thank you for joining us.
Thank you for the invitation.
Very pleasant evening. Thank you. And as I said, both these professionals are also colleagues of ours. A lot of these discussions are discussions to be had in class as well in our postgraduate degrees. Hopefully the first of many webinars online. Our viewers, thank you so much for joining us again. And let's draw it to a close. Thank you.
Thank you to the attendees.
Thank you, attendees. Yes, absolutely. Have a good evening.
Bye.
Bye-bye.
Bye-bye.